just for you guys. Okay, so I'm recording this. This is, I don't have a opening panel, but this is a Wednesday, April 28th. It's semi-class 11 of packet 6. And we're playing a game today. At least I'm showing them the rules, and I'll let them kind of play with me. And so look, if you can see, look at the screen there. Hopefully both these come off on the video, but maybe I'll redo this later. But anyway, so we have these different arrows. Let me get rid of these. Okay. So here's the puzzle pieces. Now, if you look at 6.3, number 1, we have an F-15 fighter. And the F-15 fighter is, now it's moving above right horizontal at 60 degrees. That's the part of the game that we had to drop. So we are not limited as to the direction of this F-15 fighter, okay? I'll color code this for you. We have 7 vectors, 1, 2, 3, 4, 5, 6. There's supposed to be 7. Missing 1. Oh, crap. Somewhere that I lost one. Okay. I'll make it this one. And I will make it red. So the red little stripe there. Okay. I had another one in there. It doesn't matter. So there's my different vectors if this shows up at all. Now, here's the rule. We have to first, we have to do the free body diagram using the right lengths and the right orientations. This orange one, this is the, if you're looking at that screen, either screen, I guess, this is the MG. So this is the weight of the F-15. Okay, so this, I know that this one has to be pointing down. So down is going to be towards me. Okay, so that down, that's down. And then this one, now, I gave them 7 vectors. We're only going to use 5. This is the normal force. And I let them think about it for a while. And finally, they realized, wait a minute, there is no normal force in this case because the F-15 is floating in air. So there's none of this. No solid contact. Are we getting a reverb? That sound should be off. So it shouldn't be, if you're hearing my voice, if you're sounding weird, let me know. So this one, this black one, we didn't end up using. So I'll put that over there. This one is a force of thrust, this white one, force of thrust. So the engines are firing, it's shooting out, it's like almost like F-15, like a rocket, it's shooting out all this gas, and that's getting it to thrust. So somewhere I'm gonna put a white arrow. That's poor choice for this surface. This is air drag. This one represents air drag. So I know that this is always opposite the direction of motion. It's this brown one here, this basic wooden one. This one represents lift. It's white with black stripes, kind of see it there. This has to be perpendicular to the direction of motion. And this red arrow is the summation of forces. Oh, and this arrow is buoyancy. Now, I'm not saying and buoyancy is always an arrow that's straight up. I'm not saying there's not buoyancy on an F-15. It's just that it doesn't play a big role. It's negligible, okay? So we don't really include buoyancy and we don't include normal force. So these 2 arrows I can get rid of. All right, so we have 5 arrows here in our game. And the students then, knowing all that and giving them the rules that the direction of motion will be the summation of forces, always goes in the direction of motion, that if you look at this white screen, at the white table here, this drag always opposes motion. So you'll always have to have that combo where the red is the direction of motion, the wooden one there is the drag, and then this being the lift always has to be perpendicular. So there's rules to this puzzle. You can't just namby-pamby put arrows together. The last one we did last week or early this week, that was easy because they just had these arrows, these colored arrows had to help, these colored arrows had to hurt, and then they could but here we have specifics. So this guy has got to be lift. Now lift is not straight up. Lift is perpendicular to the direction of motion. So that has to be, in a free body diagram version, that has to be a combo. But if it's head to tail, I'll move this right here. Oh, that's a problem because this is my summation of forces. So this has to go from the first tail to the last head. So I got to be careful on that one. That's okay. But that's going to have to go like, this one's going to have to go like this, because remember, head, the resultant always goes from first head to last tail. So I'm going to make this, by the way, will help you work a very significant problem on the test tomorrow. It doesn't involve wooden arrows, but it does involve vectors. Okay, so I got that. That's already set. I know that has to look like that. There's nothing I can do about that. Any questions on that set, on what I have so far? Those three. I got two more to put into my system, but any questions on that? Can you see it? You see it maybe on this scene better. So this is I'm saying that's the direction of motion. I just willed that to be the direction of motion. I guess I could have done that. So we can go ahead and follow the rules. It says 60 degrees above right horizontal. Okay. So that's 60 degrees above right horizontal. And then this guy comes like that. So now we're following the entire rules. MG has to be down. So MG and has to be head to tail. So I can't put the MG over here. That's tail to tail. So I put the MG, you can still see that, on the screen. We'll run off the screen here. The MG, then I got to put it over here. Okay, now the thrust is the last one you do. Go, wait a minute, my thrust arrow is nowhere near long enough, but that's why I let them add. We had a little extra wide arrows, and so you could add in as many as you need to make thrust work. And so this is thrust. I'm going to throw that in there. I'll throw that in there, and boom. Those three, and that's pretty close. I mean, it's not going to be perfect, but that's pretty close. So that is my head to tail. So they had to show me that. Then I went around and took a picture of it, and I'll show those pictures. I'll show the pictures to you on the screenshots. All right. Now, so that right there, all of that right there is all one arrow. That's my thrust. So this is viable. This will work. Now I've got to take all these arrows and put them into a free body diagram. Now somebody tell me, and I don't have the chat up, I have too many screens up, but you got to tell me, which arrow do I get rid of when I do the free body diagram?
Summation of forces.
Summation of forces. So this guy, this red arrow it did its magic. That's what it's supposed to do in a head to tail, but now I don't need it. It's not used for a free body. So I get rid of that. And then I got these arrows. It's really 4 arrows. That's just one big long arrow. These 4 arrows, here's the trick. And some of them didn't quite get this. You have to keep, the link's going to stay the same, but you have to keep the orientation the same. So people would slide them and they go, okay, I'll put that right there. No, you messed up right there. You cannot change the orientation. So you put this where it goes. All free body diagram means they all come from the same spot. This guy's going to come just like it was. I don't change it. This, this will go just like it was. See, now I messed myself up. Daggone it. Hold on. I got to check this again. Daggone it. Okay. Pretty much. All right. So that is kind of parallel. Okay. Just happened to be that way. There's various, and some people crossed over. It's okay. I'll show you different pictures. People have very unique ways of solving this. Now, carefully get rid of that. Move this, not changing its orientation. Move this. You're not going to do perfect, but move this. Move this puzzle piece to there. And then the thrust is going to go boom, boom, boom. I'm running off my sheet. It's much easier to do on a table. Okay, thrust goes like that. And that, then they had to draw. So they had to draw the head to tail and they had to draw the thrust. You go, well, Mr. Askey, why even do head to tail? Why not just start with the free body diagram? Well, you could probably get a feel for but there's no way you get the links. There's no way you would know on a free body that you had to add up 4 of these arrows to make the thrust. There's no way you get that length right. You might get, you can say something about MG and all, but you really can't say. So that's why you have, the only way to do this is with head to tail first, then go to your free body diagram. Okay, so that's, and then we took a picture of this, and that's all. We only had 30 minutes. Okay, so that is the recorded part of this. I'll put some screenshots up and add some examples. But now, what you all came here for, and this is where I'm going to turn the recording off. This is only for live people, only a live deal. Here to all this. So I'm going to change this around and make it better. And I had a couple students, it doesn't help you as much because you sat and watched me do it, but when you have to make the puzzle yourself, it really forced some kids to finally start to understand what vectors are and there's rules. So I think that's a good thing. And I'll write it up and submit it to other physics teachers. Okay. So now, and I can turn this one off. I'm kind of new to this game. I'll just go ahead and have this guy get out of there. I don't need him anymore. I'll just have him leave the room. Leave. Okay. Now, got rid of that guy. It's gonna be a jerk anyway. All right, so oh, I gotta stop recording. Zoom recording here. All right, so I gave them some Easter eggs. If you can bribe them to give them, tell you if you're watching this. But I think that should be live, and you should have come to class. So, you know, yeah. So anybody have a question on the test or on what's handed in or logistics before we sign off? Okay. Well, you guys are free to go. If you want to stick around, ask a question, I'll stay online until the last person leaves.